Hi guys, so this is my next video in the sequence of engineering models, and today I will be discussing about the hydraulic arm. So let's first take a look at the model of the hydraulic arm so you guys can have better understanding in the future slides, in the further slides. So this is the basic model of the hydraulic arm. We'll be working on it and designing it. You all guys can have a look from all the sides. This is how it looks. So in today's video we will be talking about the basics of hydraulics. Then we will move further and take a look at hydraulic drive systems and talking about some of its concepts. We will also see our CAD designed hydraulic arm and talk about it functioning, and then we will see some of the applications. So when I'm talking about the hydraulics, I'm saying that it is any type of technology which operates via pressure difference or force due to liquid pressure or any other properties of fluid. So if I'm using any type of property of fluid, be it pressure difference, be it velocity, to generate some sort of work, that comes under hydraulics. So when I'm specially concentrating over the pressure difference, I am generally using the term hydrostatics. So hydrostatics is the energy transfer due to pressure difference, and there is no role of kinetic energy. So when I'm talking about hydrostatic, guys, I'm like least concerned about the velocity or acceleration of any particles. I am just concerned about the pressure difference occurring in the system. So hydraulic drive systems works on the same principles. They are the system that uses the basic laws of hydrostatics to operate any hydraulic machinery. As you can see here, I am just using a pressure difference system arrangement to come out with any sort of work. So when I'm talking about the hydraulic drive system, I'm generally like considering the basic laws. So one of the basic laws that govern these hydraulic drive systems working is the Pascal's law. So the Pascal's law states that pressure change occurring anywhere in a non-compressible fluid is transmitted throughout the fluid such that the same pressure difference occurs. So Pascal's law generally states the things for non-compressible fluid, but we can also use some amount, like some sort of I'm not saying that 100% Pascal's law is true for compressible fluid, so it will be like 50%. So if I want to formulate this Pascal law in a single formula, I will say that F upon A is always constant. So let's understand it better. So in this picture, there is a piston cylinder arrangement with area A1 and piston cylinder arrangement with area A2. So when applying some kind of force F1 over the piston with cylinder A1, that force will be generated throughout. So considering this cylinder arrangement, so I will be getting a force F2 upwards. As the Pascal's law states, I will be getting a force F2 upwards. So if I am changing the area A2 with different say numerical values, I will be like getting different values of force F2. So it will be like very much possible for me to design any kind of system that can like lift heavy loads by just applying a small force at the one end. So this is the basics of Pascal's law, and it finds its application in various industries. So let me just talk about some of the applications of Pascal's law. Here it comes, it is the hydraulic press. Hydraulic press is any type of press that can be used in manufacturing processes, and that works on the same principle of Pascal's law. If I'm applying some kind of force F1 at one side, I will be generating a force F2 on the other side. Then I have cylinder arrangement in hydraulics. So in hydraulics, the cylinder arrangement is when you are using multiple cylinder piston arrangement connected via multiple tubes. So if enough fluid flows in that tube, so if you are applying some kind of force, you are like deflecting a piston in one cylinder, you will surely get a deflection in another piston when it is joined to that piston cylinder arrangement. Then I have braking systems. So in braking systems, we use the basics of Pascal's law. If I'm applying the brake pedal on one side and I'm like deflecting the piston, that piston will ultimately result in application of force over the fluid, and using the Pascal's law, that fluid force will be generated throughout, the pressure difference will be generated throughout, and I'm getting a different force at the other end to drive the brakes, the disc brakes in there. It's very useful, guys. And I'm also take hydraulic lifts as an example. So hydraulic lifts are the lifts which, instead of using a pulley and thread connection, pulley and rope connection, use hydraulics. So applying some kind of force at one end, I'm getting deflection at the other end. So these were the basic applications of the Pascal's law. So when I'm talking about the hydraulic cylinder arrangement, it is the basics of the Pascal's law. So I just need to have a piston cylinder arrangement and some amount of tubes to generate any sort of work. So let's guys take the look at the model to have better understanding of Pascal's law and the hydraulic piston cylinder arrangement. So let me just first name all of my parts. So I'm saying that this is cylinder 1, this is cylinder 2, and this is cylinder 3. Cylinder 1 is connected to cylinder 1 dash, cylinder 2 is connected to cylinder 2 dash, and cylinder 3 is connected to cylinder 3 dash. So using the Pascal's law only, I will be generating some amount of force at any of the piston that will deflect the fluid inside, and that fluid will cause same amount of pressure occurring at the other end, and I am just generating some amount of force so that I can do any type of work. So let me just take an example that I have to like pick some amount or some item kept on a table. So I'm using this hydraulic arm to come out and work. So here, when I need to just deflect this, or I just need to move this arm, I need to move this piston which is like connected or like touching this arm. So this piston must be moved. So that piston cylinder arrangement is connected to the cylinder arrangement 3. So when I am getting some amount of, I'm applying some amount of force in the piston 3 like this, I will be getting some force at this. So I will be lifting this arm in that case. This is how it works. Similar is the case with the other arms. Like if I am applying force at the cylinder 1, I will be getting some amount of force here using the Pascal's law, and same is the case with the piston 2. I'm getting some deflection here. So this is how it works. You all guys can create this type of piston cylinder hydraulic system at home. This is the basics, and you just need to have piston cylinder arrangement. You can use syringe in that case. You just need to buy some tubes from the market, and you guys can connect different system piston cylinder arrangement to one another, so you guys can use the basics of the Pascal's law to generate any sort of work. Then you need to just fabricate or design 3 arms, the arm 1, the arm 2, and the arm 3, to move these arms using the piston cylinder arrangement. And these arms must be joined via insert joint, so that these arms like free to rotate over these axes. So these are free to rotate over these axes, and these are in turn moved by these piston cylinder arrangement. I hope guys liked my video. If you liked my video, please share it, subscribe it, and please take a look from all the sides so you guys can have better understanding. This is how a normal hydraulic system using simple piston cylinder arrangement works. Thank you guys for watching. Have a nice day. Bye bye.